Good evening, everyone, and good morning to those who have just started the day. Hope you all are safe and sound. I once again welcome you to this webinar on behalf of Core Data. My name is Mohammed Abdullah. I'm working as an IT business consultant. I'm your host for today's webinar on the world of predictive analytics. Before I introduce our speaker for today, I'd like to say a few words about Core Data and its services. Core Data is an all I'm sorry, can you guys hear me? Okay, anyways.
Yep. Yes, we can hear you fine.
Okay, perfect. Sounds good. So I'm just giving a brief intro about Core Data and its services. Core Data is an all-in-one data analytics and integration company hustling across industries like pharmaceutical, retail, biotech, and life sciences. We help businesses future-proof their solutions, deepen their understanding of consumers, increase competitive advantage, and unlock operational efficiencies. Next slide. Our IT solutions have helped companies across Europe and United States automate and optimize their operations to make their lives easier. We're based in New Jersey with offshore offices in Lahore and Karachi. Next slide. We have quite a few significant partnerships. To name some, we're Microsoft Gold partners in data analytics. We are also RICI certified information security management system. Next slide. Our team consists of expertise in machine learning, data engineering, and analytics. Our services enable pharma, biotech, and device companies to making the most of their data. We ensure companies implement data-driven decision-making across their business functions, such as compliance and marketing. Now, without taking more time, I'd introduce our speaker for today, Mr. Danish Haroon. I'll give a brief intro of Danish. Danish Haroon has been a renowned name in the data analytics industry for over 7 years. He has been a part of many top organizations such as K-Electric, Predictify Me, and Market IQ Inc. He is also an author of a critically acclaimed book on machine learning. On behalf of Core Data, I welcome Mr. Danish Haroon. Thank you so much for taking out, Danish. Now for handing over the virtual show to you. Just a quick note, if anyone has any questions at the end of the webinar, we have kept a Q&A session. For those who have any questions, they can write in the question box and we'll get back to them at the end. Over to you, Danish.
Abdullah, thank you for the introduction. Hello, everyone. Welcome to this exciting webinar, where you will learn about the ins and outs of a general perspective to predictive analytics. We are very fortunate to be in times like these where businesses are ready to challenge the status quo and let analytics do the talking for solving their business problems. And indeed, we are very fortunate to be in times like these where we have that much compute at our disposal to answer the questions which were a mystery before. So what to expect from this webinar? You see, when we are using data as an aid to gain more deeper insights about our business, the transformation is subject to happen in stages. And so you will learn about those stages and where does the predictive piece fits in. Then I'll use human behavior as an example to explain the nuts and bolts of predictive analytics. Then I'll shed some light on a life process, life cycle of predictive analytics. So for someone who wants to pursue his career in this domain, or for someone who plans to incorporate it in the business processes, there are some prerequisites, or we can say things to consider before moving forward. So we will talk about those as well. And then towards the end, we will talk about some of the recent developments in this arena. And we will conclude with mentions of some of the business use cases where we brought value to by means of predictive analytics. So Back then, once businesses started collecting data, they began using it in their own capacity to answering questions. At first, they were able to answer questions like, by means of this data, what happened in the past? Was it good? Was it bad? And this they were able to do by simple aggregations, be it the sum, an average, or a median. But what they lacked was the capability to learn the causes or say reasons which led to those outcomes. Then the next wave came in, which enabled them to drill down for deeper insights, finding out relationships, and learn about the inner trends and seasonalities. By this, they were now able to deduce the reasons which led to those outcomes. And so by means of these descriptive and diagnostic analysis, they were able to use this historical data, the behaviors and distributions within those, and thanks to the compute which was now available, to sneak peek into the future, or in other words, were now able to calculate the likelihoods of uncertain outcomes that might happen in the future. What came next was even more fascinating. Machines have now become smart enough to provide recommendations that are tailored to your needs while keeping the overarching business objectives and future outlook in mind. So we as humans use our experiences to learn and to move forward, right? And so many times we are in a situation where we need to decide between two choices, with one of them being relatively better than the other. Some of the times we take the right choices and some of the times we don't, right? And on the basis of these choices or outcomes, we as humans mature in our decision-making skills and moving forward, start making even better choices. A child usually relies on the decision support system of his elders, right? And the reason being that the decision-making skills, model, or we can say its signature of elders is relatively more mature enough. But as the age of that child progresses over the years, he might be exposed to some new situations and experiences. And it might be that his elders didn't go through the same experiences. If that's the case, then their decision support system might recommend choices that might underfit. Thus, in that situation, if you take decisions on the basis of those recommendations, then the outcome might not be in your favor. And that is when you start creating your own decision support system that inherits some signatures from your elders and some signatures that are tuned to your own new experiences. And that is precisely how predictive analytics works. It uses the previous experiences, inner distributions, and behaviors within the past to find out the likelihood of what the future beholds. There are times when a feature drift can happen. By that I mean the behaviors might change moving forward. And thus, there will be a need to retrain the decision support system by incorporating the information that was not deemed necessary before. So, a general misconception among people is that predictive analytics just has to do with machine learning. However, the scope is much, much more bigger than that. So usually we start by understanding the business processes through a thorough audit. Try to find out the opportunity areas or say loopholes, and then classify those in the stages we discussed earlier. We then rank those business areas by means of the potential ROI and pick the most priority ones. Then we start looking for the data sources that have rich features and enough experiences to build a solid decision support system. Once the data is there, we apply descriptive and diagnostic analysis to basically have a feel of the data to see if there are some areas of concern within the data, be it the data quality issues, be it outliers, be it missing values. And then we fix them by means of transformations and imputations. We also look for potential correlations and relationships among features. And we also look for temporal features like trends and seasonalities. The model is trained on a subset of data, right? But when the model is put live in the real world, it will be exposed to unseen data as well that it wasn't exposed to during the training phase. Even then, we would want the statistical model to generate good forecasts, which means that it should generalize well on unseen data. So for that purpose, we split the data set, whereby one set is used to train the model, and on the other set, we apply the learned model and find the accuracy to check if it generalizes well on that set. If it generalizes well, then we can be confident that it will perform good on the unseen data as well. We then use the findings from the descriptive and diagnostic analysis we talked earlier to come up with a statistical model which can help us foresee the future. For this statistical model to bring utility within the existing business processes, we will have to deploy the model, nature of which can vary from case to case. It can be in the form of a presentational layer with visual forecasts and recommendations. It can be in the form of a data product, be it a website, mobile app, or IoT integration, which uses those predictions to automate business processes. The story won't end here. A constant monitoring of the model is important to see its performance over time. There might be a need of intervention if a feature drift happens, or in case you believe the process has to be made more leaner, or at times you believe that an additional piece of information is now available, which can further improve your estimations. So when embarking on a predictive analytics journey, you need to take into consideration the following prerequisites. The problem in reference should align with the overarching corporate strategy, and that problem should have a sizable anticipated ROI. Now, the change management side of things is pretty crucial on two fronts. So one front has to do with when you're trying to understand the processes and gather the business requirements. So these requirements will be shared to you by the business users, right? And it is on him the amount of information he would want to share with you. For that, it's important that you make him realize that you are there to help him and share the vision with him as you see it. As soon as he realizes that he has stakes in this initiative too, the sense of security will vanish, right? And he will go beyond bounds to help you. If you avoid it, then there are chances that your solution might not be a business fit, and thus no utility will be generated out of it. So change management is also important and crucial when the statistical model is developed. And you pivot your processes such that you will now be incorporating the feeds from that statistical model for decision making. If change, be it process re-engineering or reliance on those recommendations, if those changes are too abrupt, then there are chances that there might come a mass resistance from the business users. They might either not use it or try to look for shortcuts to bypass it. Therefore, a better practice is to approach that ideal goal in baby steps to make the business users susceptible to change and climb to a next level of maturity only when you believe that they have reached a good degree of comfort in the earlier stage. Therefore, as much as it's important to have high accuracy models, it's also important that your solution is a business fit and generates utility. Finally, there can be times whereby the statistical model predicts something or generates recommendations that you as a business user might not deem good. This can be because the model is not 100% accurate and might not generate the right insights all the time. But it can be that the model foresees something that is right and is contrary to your understanding. Hence, it is essential that you give those recommendations a due consideration. That's because if the model is 90% accurate, then 9 out of 10 times what it says is right. So data quality is very crucial, such that if there are missing values, there are outliers, data types are not consistent due to lack of validation checks on data input, then obviously that would mean that either you missed a major proportion of the data, or it can be that the transformations or imputations make the distributions deviate away from the true representation. And so it's rightly said that a machine learning engineer has to spend 80% of his time in activities like data wrangling, visualization, and transformations. Our world works in a cause and effect relationship, right? There are numerous factors responsible for every event that occurs. The data you use to train your model should account for as many relevant features as possible to help model the business processes. There can be instances where you might have to consider data from public sources to help bring you closer to the true distribution. However, high number of features would mean that the problem complexity will increase, something that is called curse of dimensionality. Hence, it's important to only use the features which have a strong influence on the target variable and remove or combine localized features. We talked earlier about feature drifts that can come after the model is put live on production. However, there can be cases where your training data has feature drift too. If the case be, you might either use only the recent behaviors or model those behavior changes to help your model survive even in the presence of feature drifts. The fact is, the more experiences the model is exposed to, the better it can learn. Thus, a high volume or a huge amount of data can generate a strong model. However, it stands true only if the high volume of data has diversity in terms of experiences. Otherwise, the model will overfit only to a limited number of experiences and underfit on all others. So when we say something should be deterministic, we mean that for a given set of inputs, it should always come up with the same output, right? When benchmarking different statistical models, training an existing statistical model, or when collaborating in teams, it is essential that the model should be reproducible, such that the results you report can be regenerated again. The tip here is to set the random seed to a fixed value so that it always starts from the same point in the error space. There can be instances where you see a strong correlation between a feature and the target variable. But before using that, you should also verify if that feature is available for the future time horizon, on which you are planning to generate the forecast for. If not, then it's better to forego that feature, as it will be beneficial during the training time, but can't help you generate forecasts for the future outlook. From problem to problem, your accuracy benchmarks might vary. These benchmarks should match or exceed the current best practice. One should start with simple statistical models and only if need be, attempt towards a more complex model. However, complexity is directly proportional to compute and you can say inversely proportional to efficiency. Therefore, one should keep in mind the available compute and frequency of requests during runtime before moving to a more complex model. And for sure, it goes without saying, if a tried and tested out-of-the-box service is available that can cater to your business needs, then it's better to use it rather than recreate the wheel all over again from scratch. This will save you time and would mean that you won't have to worry about data sourcing, cleaning, and compute for model training purposes. So there have been some recent developments in this domain, and here I will shed light on some of the more significant ones. It has not been a long time ago when, in order to work on predictive analytics, you had to have an environment set up, had to have a good compute and incur a sizable capex to work on complex problems. But times have changed now. Thanks to cloud compute, time to development has considerably reduced without you having to worry about the compute and environment. As the complexity of your model or the approach increases, the compute will scale automatically with close to 100% availability. And the interesting part is that you pay as you go, with some services which are even free of cost, and the collaboration within teams has taken it to a whole different level. And this leads me to another development, that is the advent of modular data pipelines. Tools like NIME, RapidMiner, Azure Machine Learning Studio are some of the modular development platforms that allow you to build machine learning pipelines without having to write a single line of code. If you don't find a functionality within these platforms, then there are even options that allow you to incorporate code snippets if need be within your modular pipeline. So one significant breakthrough has been the advent of variational automated coders. You might have understood by the name. VAEs comprise of two modules, an encoder and a decoder. Encoder encodes the input data into a lower order representation, and decoder reconstructs the original image from the lower order representation. This is obviously good with respect to the compression side of things. You can think of the lower order representation as a distribution of the net data, and thus it can be used to generate new data as well. Recently, researchers have built up on the concept of VAEs to introduce some new variants, one of which being the disentangled automated coders. This specific variant gives you control to select the type of new data you would like to generate. Certain other variants of variational automated coders are used for image completion to remove noise from the image. And noise here can mean a watermark as well. Moreover, there have been cases where VAEs were used to even convert a lower dimension image into a higher resolution counterpart. So quite powerful a discovery, I would say. Now these graphical processing units. So earlier GPUs were preferably used for gaming because you need a lot of compute for games, rendering and all. But later on, they found out that GPUs were really great for AI algorithms, as they comprise of large number of cores, which help in parallel processing. So in Internet of Things and the IoT networks, model training usually takes place on the master node instead of the edge nodes or the edge devices or the sensors. However, this requires data transfer from the edge devices that raise concerns of data privacy, data security, and bandwidth issues. That is where federated learning comes in. It allows model training on the edge nodes with weights then transferred to the master node for reconciliation. As weights are transferred instead of the original or actual data, this means that data is not at risk and with less burden on the bandwidth. So following are some of the project mentions on which I worked on personally. And so these projects range across domains of retail, logistics, utility, and banking. So the first one I would like to talk about is the promotion tools. So you see, business managers usually run promotions to boost up the sales of their portfolio of items, right? And so those promotions can be buy one get one free. It can be you can buy a pack of 5 for $2. It can be a percentage discount as well. A promotion can have a single item, or you can say a collection of items as well, right? So promotion can be a part of the ad. That is, you can market that on some online channel and have an in-store marketing as well. Then there are some nitty-gritties in terms of the ad, such that you can market that on any page or position within the promotional circular. So the client here was interested to know how much sale uplift should they anticipate on running a specific promotion. So we created a solution for them, and it also helped them get a sale boost on items that weren't doing that good. It helped them maintain enough inventory to avoid stockouts, and suppliers were able to make sure that the supply of items and the goods is streamlined, and there are no issues from a sourcing point of view. Then the other use case I would like to talk about is the supplier churn analysis. So in some markets, there are, you can say, retail brokerage houses. So what they do is to build relationships and maintain documentation between the suppliers and the customers. Here by suppliers, we mean Topcos and Walmarts of the world. The suppliers are interested in getting their products shelved in the stores of these customers. So on each transaction that happens between the suppliers and customers, these brokerage houses get a commission out of it. So some time ago, they noticed that a huge number of suppliers were turning away. And upon investigation, they found that it was primarily due to less number of orders from the customers, right? Hence, in order to avoid further damage, they went towards a more proactive approach to forecast the anticipated sales of each of their suppliers. And so this helped them take necessary steps to ensure the retention of suppliers. So there's this utility company is there in one of the largest metropolitan cities of the world. The utility is faced with the problem of electric power theft, whereby customers bypass their meters by unlawfully fetching power from nearby feeders. This means that the true consumption won't be reflected in the utility bills, and the utility company has to be at a loss. So we helped them by creating customer profiles to answer questions like which customer will incur theft in the future and in what point in time. And so this enabled them to perform targeted site inspections to reduce the distribution losses. So there's a bank in Africa with a huge network of branches across different cities. So within each branch, they have designated counters for different types of services. So many times they faced the problem whereby some counters were crowded and the others were underutilized. This meant that customers on some counters had to wait for a long time for their turn to come, whereas there is idle staff on the other ones. So we created a solution for them to let them know in advance how much traffic on each service should they anticipate on a per hourly basis. This helps them reallocate the resources on runtime to reduce the waiting time and ensure that the customer experience improves over time. So for the same utility company we talked about earlier, they have a team of meter readers who visit the customer premises on a monthly basis to fetch the meter readings. This means that they punch in the consumption information within their smart devices and take the snapshot of that meter as a proof. This data is then sent to the central server and is screened by data processing officers who are overwhelmed by the volume of data they need to go through. So the solution was a deep model which automated the screening process, and it only exposed the data for screening on which it wasn't sure about. And so this decreased their workload by 33%. So I hope you gained a fresh perspective from the session. Abdullah, over to you for the closing remarks.
Thank you so much, Danish. It was indeed a very full of knowledge session. We take questions now. If anyone has any question, they can either ask them or write in the comment box, and we'd be able to answer them. We'll wait for a minute. If anyone has any question, they can post it right there, and we'll be more than happy to answer. Okay, perfect. I think we're good. Nobody has any questions, and even in case, like, if anyone have any questions, they can just write it to us. And thank you so much for taking part. Thank you so much for participating in this webinar. And we're like more than happy in the future as well. If anyone wants to write to us, they have their email addresses. They can just write to us. Thank you so much, everyone. Have a good one and stay safe.
Danish, one quick remark from Shahan. The question is, what analytic skills are essential for the industry use cases you cited?
Yeah, so obviously the skills are subject to use case, you see, and so usually the skills that are required, for sure, you need to know about how to slice and dice in the data, how to source the data, and how to like clean the data, apply transformations on that, and obviously you should also know that how to apply the algorithms, what to do when with respect to which data, what steps should you take, and then towards the end you should able to foresee as well that how can I generate the utility by means of the algorithm or by means of the solution I've developed, right? And so you need to look from end to end, and you should have the capability as well. so that you should know about from the sourcing point of view to the algorithm point of view, and all the way to the presentation view as well. You should know that, okay, if I need to go about creating this visualization, you should be able to model that, you should be able to wireframe that, you should be able to communicate that to the business and get the say on that. So obviously it has to be an end-to-end cycle. You should know from the start all the way to the end. And so for that, it's important that you should have a know-how at least, and you should have a fair amount of hands-on experience on that, so that you can help the business users as well, and so that you can delegate the requirement to the respective teams as well, to create the project and to basically join the utility by means of putting that into production.
Thank you so much, Danish, for answering that. Um, Sean, if you have any other question, you can just write it to us. If not, then we'll end the session right now. Okay, I think we're good. Then thank you so much, everyone. Thank you so much, Danish, for taking our time. And we'll speak to you guys again. Take care and bye-bye.